Problems from section 2.4. Number 3. So f of x is a quotient problem. So the format for a quotient is derivative of the numerator times the denominator minus the derivative of the denominator times the numerator all over the denominator squared. So derivative of the numerator times the denominator is secant x. Derivative of the denominator times the numerator, that's tangent x minus 5. And there's a subtraction in there, so that's why I'm putting parentheses around it. And the denominator squared is secant of x squared. Now the derivative of the numerator is, so this is a sum, but the derivative of the constant is 0, so I just have to do the derivative of the tangent of x, and the derivative of tangent is secant squared of x minus, and the derivative of secant of x is secant x tangent x. Now, this is secant cubed. This has a secant, so I could factor out a secant out of these two and cancel one of the secants if I wanted to. But that's what the derivative is. And then if I want to find the derivative at 1, I put 1 into all of this. And let's just do that. Let's see, I'm going to put my calculator here. Just had it. There it is. And some of you are having trouble entering stuff in the calculator. So let's see here. Put it where you can see it and where there's minimal glare. That looks pretty good. So might be easiest to type it into your function and then do y1 of 1. That way, if we got a mistake, we can come back and work on it in here. So it's secant squared. Secant is 1 over cosine. So this is a fraction. I'm going to use this feature on the calculator. Math, go to fractions, and it's a numerator over denominator. And so now I get to put in the numerator. And secant is 1 over cosine. So that would be cosine to the negative 1. But this is squared, so it's negative 2. But this is another secant, so it's secant to the minus 3, cosine of 1, or x, close parentheses, that whole thing, parenthesis, cosine of x, close parenthesis, not just the x to the minus 1, but the whole thing to the minus 3. Minus secant, which is cosine of x. If I close the parentheses, then I put the minus 1 on, and I can do that by pushing x to the minus 1 button on the calculator. That's going to do secant. So it's the whole thing to that, not just the x. Tangent of x times the quantity, tangent of x minus 5. Close the parenthesis. And in the denominator, I have secant of x, which is 1 over cosine, but it's squared, so I'm going to do cosine of x, close parenthesis, to the negative 2. And then I'm going to quit. And I'm going to do the y1 that was in y1, bars, y variables, function y1 of 1. And I get 4.747. I'm going to check my answer here. I'm going to go and put into, I'm going to turn that one off for the moment. I'm going to go to y2 and type in my original equation, which is a fractions, math, fraction, numerator, denominator, 10x minus 5 over secant x, cosine to the minus 1. Okay, and I'm going to graph that, and I'm going to use zoom 4. And we're supposed to find the slope at 1, which is right about there. So I'm going to do, please calculate the slope at 1. And it says the slope is 4.747. So I did it doing the calculus method, and then I did it using the graphic method on the calculator, the calculus method of the calculator graphing. Okay? So now you got a way to check your answers. So now let's do 4. So we have a quotient rule. We have a product in the numerator, but we have the bigger picture as a quotient. So I got minus over something squared. The something squared is secant of x squared. Oops, I got the square. All right, and then we have derivative of the numerator times the denominator. Derivative of the denominator times the numerator. But the derivative of the numerator is a product. Derivative of the first is 4x times the second plus the derivative of the second, derivative tangent, is secant squared x times the first. These are all times, plus in between, so we've got to put parentheses around that. And the derivative of the secant is secant x tangent x. A big mess. I could put this together and call this 8x to the third, except that's only times this, and let's see what it is. It's 4x times the first part, and this 2x squared is times that part, and this is not times this, and this is not times that, so I can't put those together. So I have this complicated mess. I could factor out 2x out of that numerator, or out of that mess, but and I can factor 2x out of this, but it's not going to make it a whole lot easier. So now I'm going to go type that in. So I'm going to delete everything I have in the numerator here from the last time, and delete everything in the denominator. Whoop, I deleted the fraction. Math, fraction, numerator, denominator. So I've got a parenthesis, 4x tangent x, close the tangent, excuse me, plus secant squared cosine x to the -2. So that makes it, the cosine becomes secant times 2 x squared, and that's the first derivative of the numerator, and that's times the denominator, which is cosine of x flipped upside down, close the parenthesis, flipped upside down, and now I have minus cosine x flipped upside down so that it's secant, tangent x times, close parenthesis, 2x squared, another tangent x. So I could have squared the tangent x, but I'll just write in tangent x. That's the complete numerator. And then I'm going to the denominator, and it's cosine of x to the minus 2. And I'm going to quit, and I'm going to go back to y1. And so we're supposed to do this at 3. So I'm going to bring this up, and I change the 1 to a 3, and now I have my new y1, and I get negative 16.126. Now let's check our answer like I did before. So I'm going to go up here, turn that one off, come down here and type in the new equation, which was, delete everything that was there and write in, get it so you can see it, 2x squared tan x. That should be in the numerator, and I didn't do the fraction thing first, so I have to put parentheses all around this. Second insert of parentheses, divided by secant x, which is cosine x to the negative 1. And now if I push graph, I'm going to see that graph, and we're supposed to check for the derivative at 3. 1, 2, 3. Yes, it looks negative. It's going downhill and really steep. Let's find out. Second, calculate the slope at 3. Enter. Negative 16.126. Says it right there. Okay? All right, let's find the equation of the tangent line to y equals 2 tangent x. Well, the equation of the tangent line is at a equal pi over 4, where the x value is going to be the derivative at a, x minus a plus f of a. That's the definition, but our f is our y here. The derivative of 2 tangent x is 2 secant squared x, and we're going to value, so we're going to have L of x is going to be 2, but we're putting in a, 2 secant squared of a times x minus a plus f of a, so that'd be 2 tangent of a. And a is pi over 4. So now let's calculate the slope, which would be just this first part. So I'm going to quit this, and I'm going to do 2 secant of pi over 4 minus 1. So that's the secant. Oh, it's supposed to be squared, so minus 2. That'll be this, which is 4 times x minus a pi over 2 plus tangent of pi over 4. Tangent of pi over 4 is 1, so plus 2. So this would be the equation of the tangent line, but they said, what's the slope? We got 4. And what's the y-intercept? Well, that would be 4 times pi over 2, which is 2 pi, because the 2 goes in 4, plus 2. If I work that out in decimal, that would be 2 pi plus 2. In decimal, it's approximately 8.28.